Guys, welcome back. So we're gonna start chapter 7. So we only have two sections here, and the first section we go through is 7.3, in which we'll talk about functions of several variables. So the objectives are to evaluate functions of several variables, use functions of several variables to answer questions about real life situations. All right. So let's do a quick introduction. So in real life is rarely we're gonna see a model of a problem of one input and one output, right? Which is what we have been working on throughout the semester. It's actually more realistic to have a function that depends on more variables. And so here are a few examples. If I put a deposit into an interest bearing account and let it sit, the amount that I have at the end of the 3 years depends on P, right? How much initial deposit I put in also depends on R, the annual interest rate, and also it depends on N, the number of compoundings per year. Another example that we have is the air resistance on the wing. In a wind tunnel depends on the shape of the wing, also the speed of the wind, also the wing's orientation, and other things we can haven't be able to discuss, right? The amount, we also have another example. The amount of your television cable bill depends on which basic rate structure you have chosen, and also on how many pay-per-view movies you have ordered. So basically, in the real life or real world, it is a little more complicated because it depends of more variables. So we want to make sure that we extend the ideas that we have discussed in this course of from calculus, so that we can reflect these type of functions. So let's jump in to define what does it mean a function of two variables. So let's say so usually we had originally just had a function and depended of one variable, right? What we're doing here is we're going to extend this to more variables. For example, we can treat x, y, and z as the variables. Now, because often we have a function that could depend more than three variables, excuse me, we, instead of having use letters because we could run out of letters, we typically just give them a different label. They say, oh, this variable is x of 1, this variable is x of 2, this variable is x of 3, and this way we can continue as much as variables as we need, right? We can go as much as variables as we need, right? So we don't have to be attached to a particular set of letters. We can just say x of 1 is one type of variable, x of 2 is another type of variable, and so on and so on. So these variables, as before, as we have discussed in the beginning of this course, represent real numbers, and also we could describe them. Since these are variables, we could describe them as the as a tuple, right? And we can say that these variables are have a particular order, and that is because if we had, for example, a order of 2, 3, just like we have it for the order pairs, this first position represents the x variable, and the second one represents the y variable, right? So the same thing happens here, is that the first position represents the variable for the x of 1, the second position represents the variable for x of 2, and so on and so on. So these are called n tuples, and of course these are just an extension of the order pairs, or also the order triples. So anyways, we call these the n tuples. And a function of n variables is a function whose domain is going to be some set of n tuples, and whose range is going to be a real number. So what we're saying here is that we would have a function of n, let's say 4 variables, but the output would be a single real number, right? It's going to be just a real number. You're going to input a few things, and then the output will be a real number. So that's still consistent, right? Before with what we've done before. but in this case, we're going to input more than one variable. So so much of what we do here is everything will work the same, whether we are using 2 variables or 3 variables or 47 variables. So because we're trying to keep this in objectively into the application of multivariable without going too much in or diverge too much into multivariable functions, we're just going to keep it into 2 variables, right? So you guys will see examples where we only have to deal with 2 variables, but easily can they be extended to 3 or 4 or 5, right? Depending on the type of problem that you're working on. Okay, so let's jump into to get some formal definitions. So we have functions of 2 variables. A function of 2 variable is any function that is each input pair is associated with exactly one output. So you're gonna input two things, right? And the output will be a real number. The inputs are order pairs, right? So the order matters, right? The order matters. So whether you have, if you put a number here versus if you put the number there, the 3 is has a different, it belongs to a different variable. The output are real numbers. Each output is a single real number, as we mentioned before. The domain of the function is a set of possible inputs, either order pairs, right? The range is a set of possible output real numbers. All right. So here is an example of the function that we're going to be seeing here, right? So here we have a function. We're going to input 2 values into the function, 2 different values into the function, and the output will be another value. So this will be the case where we used to have like y equals f of x, right? Where you input a number and the output was y. Well, in this case, x and y do not depend on each other, right? This y is no longer this one, right? Y is not dependent of x. So we just have to be careful, right? This is independent. Y is independent and x is also independent. So we just happen to use x and y, but they don't have the same relationship as before. The function of 2 variables can be described numerically as a table or as a graph or as an algebra or in English as well. So we often will call now the first one, this first introductory function, we'll call this a function of 1 variable, right? All right, so here we have example number 1. We're just gonna translate this into English. So the cost of renting a car depends, right, on 2 factors: how many days you're gonna keep it for, in other words, how many days you're gonna rent it for, but also sometimes how far you drive, right? So when you rent a car, they ask you how many days you're gonna rent it for, and if the rate of miles is part of the cost, then you also add the number of miles you're gonna drive. So if we want to represent the cost of this, so we're gonna let D, right, D for days, be the number of days you rent a car, and we're gonna let M be the number of miles you drive. Then the cost of the car in rental will be C of the depend. So the cost will depend on the number of days you rent the car for and number of miles you drove during the rental. So this, of course, is a function of 2 variables. So to better support you with these here are 2 examples that we can follow. So here we're given the function f of x, y, and which equals x plus y times x to the 4, and it's given they're giving us a few points if one wants to evaluate them. So what we're gonna do here is we're gonna plug in, right? We're gonna follow the order of them, and we already know that the first one is the x and the second one is the y. So what we're gonna do is we're gonna evaluate this by saying f of 5 minus f of 5 comma f of 5 comma negative 5 means that we're going to replace every x with 5, every y with negative 5, and so on, right? So this is x, so here goes x, so it'll be a 5 there. This would be another x, so that would be a 5. And then the y will be -5, right? -5. So that's it, right? So it's very similar to what we done before. All we gotta do is just do a direct substitution of your x's with your x's and your y's with your y's, right? Within one single function. And then all we gotta do is just put this in the calculator, and we end up getting -3,120, right? In a similar argument, we can do the same thing for the next one. Here we have f of 3 comma 1. And so for this example, we have x plus y times x to the 4th power, where we'll say that x is the red value, right? X is your red value. So that'll be a 3 for x there and a 3 for x there, right? So I'm just following the original problem here. And then y is going to be 1, right? And that's it, right? We just do a direct substitution, and then we compute this, which will give us 84. All right, so as you guys notice, it's just basically what we're doing is just using it as before. We just do a direct substitution of x's with x's and y's with y's. Anyways, I hope you guys found this helpful. Please let me know if you have any questions. I'll see you guys next time. Thank you. Bye-bye.